Welcome guys. Before us we have question 3 from section C of Science Paper 1 for the year 2023 for the internals. Now, as we can see, we are dealing with a question that is falling under the topic of current electricity. Now, a question reads, your home has a television set rated 40 watts that is used for 10 hours a day. A hot water geyser rated 4,000 watts used for 3 hours a day, and a cooker rated 2,000 watts used for 2 hours a day, all connected in parallel to a 240 volts power supply. Right, so question A, we just want to draw a circuit diagram to show how the three appliances are connected. Now, a circuit is a complete pathway in which current can flow. Now, this circuit diagram that we are going to draw, we need to make sure that we have three electrical appliances, and these three electrical appliances must be connected in parallel. So how can we make such a circuit? How can we draw such a circuit? So I'm going to use the space down here. Now, the first one, let's look at the TV, which is the television. This is our first electrical appliance. Since we have three, the second one, I'm going to put the geyser. Then my third one will be a cooker. Now, since they are connected in parallel, we need to have a junction. So this is the type of parallel circuit. So the key point in a parallel circuit, the voltage that goes to, let's say, each electrical appliance is equal. For example, if you go back to the question here, we are told that the power supply supplied the voltage of 240 volts, which simply means that for each electrical appliance, 240 volts was received. So here a voltage of 240, even here a voltage of 240, so is here. That's why one of the point that you need to master whenever you are dealing with a parallel circuit is that voltage is equal at all points as long as the circuit is connected in parallel. So the only part that differs for these three electrical appliances is the current. So the current that will pass through the television will be different from the one that will pass through the geyser and the cooker. Now here I'm just going to put this symbol for alternating current. So alternating current is the type of current that changes the direction periodically. So within a second it can change its direction. So this type of source has no specified current. So I'm going to use this as our symbol for this lesson. Right, so the first question we are done. Now let's go back to question B. So now for question B is calculate the power used by three appliances. So we want power. So since it's power and the excuse me, the information that we are given here, we can see that we are dealing with power. So how can we find the power in this case? So we just have to add the three powers from each appliance. What do I mean by that? Remember, I need to find the power for the TV plus the power for the geyser plus the power for the cooker. So the power for the TV is 40 watts plus geyser is 4000 watts. Then for the cooker it's 2000 watts. Then I'm just going to add the numbers. Then we've gotten our answer. So 4000 plus 2000 is 6000 plus 40. So this is 6040 watts. So this was the power used by the 3 appliances. Now we move on to question C. If electricity costs 20 ngwe per kilowatt hour, calculate the cost of using these 3 appliances in a day. Now the formula for cost is equal to, we need to have power, make sure that the power is in kilowatts, then multiply by time. The time should be in hours. So in case you are given in minutes or days, convert to hours. Then cost per unit. Now the cost per unit, remember, should be in kwacha. So let's look at what we have here. So from the data collected, we've collected 6040 watts as the total power. Then what are we supposed to do? I'm going to get this number and convert it into kilowatts. So how can I convert this power in kilowatts? I'm going to divide by 1000. So remember, 1 kilowatt is equal to 1000 watts. To change from kilowatts to watts, you multiply by 1000. Then the reverse, you divide by 1000. So 6040 divided by 1000, I'm getting 6.04. So this is my power now in kilowatts. So this is the number that I'm going to substitute here. So 6.04 kilowatts times time. Now let's look at the TV. So the television was used for 10 hours in a day, plus 3 hours for the geyser in a day, plus 2 hours for the cooker in a day. So the total is 10 plus 3 is 13 plus 2 is 15. So multiply by 15 hours. Then the cost we are told is 20 ngwe. Now we don't want the cost in ngwe. We need to change this into kwacha. So 1 kwacha is equal to 100 ngwe. So to change from kwacha to ngwe, you multiply by 100. Then from ngwe to kwacha, you divide by 100. So this 20 ngwe divided by 100 will give us 0.2. So that is the number that I'm going to use here. So 0.2 times 15 times 6.04. So I'm getting 18.12 as the total amount of money used. Then we move on to question D. So under question D, calculate the electrical energy used by the television set in the period stated in C. Now, electrical energy can be found by this formula: voltage multiplied by current multiplied by time. Now, whenever you are dealing with energy dissipated, make sure that the time is in seconds. Now our focus is for television. So let's go back to the first statement. So for television, we are told that the use was for 10 hours. So we need to use 10 hours as our time. Now remember, we need to change that hours into seconds. So 1 hour is equal to 60 minutes. Then 1 minute is equal to 60 seconds, which simply means that 1 hour is equal to 3,600 seconds. So you just multiply this number by this number. So to change that, I'm going to say 10 hours is equal to x. You cross multiply, which is x hour is equal to 36,000 seconds over HR over HR. So if I cancel, then I have 36,000. So to summarize our work, we are just saying that whenever you are given time in hours and you want to change that direct into seconds, you multiply the given number by 3,600. So the conversion factor is here. Let me just put it here. 1 hour is equal to 3,600 seconds. So from hour to seconds, we multiply by this number, 3,600. Then from seconds back to this one, you divide by 3,600. Now, the other thing that we need to look at is, remember, the power for television, it's 40 watts. Then for geyser is 4,000 watts. Then for the cooker, it's 2,000 watts. Now, what is the formula for power? So power is equal to voltage multiplied by current, which simply means that where there is VI is same as there is P. So we can change our formula from VIT to PT. So energy dissipated can be found by power times T. Why do we need power? Because we are given power, we don't have current. So the power for television is this number, 40. So that's the number that I'm going to put here, times time. The time that we have found is this number here, which is 36,000. So 36,000 times 40, I'm getting 1,440,000 joules, since it's energy. So this was the amount of energy used by the television. Now for Roman number, for question E, suggest a fuse rating suitable for the geyser. So what is your first step whenever you're dealing with fuse? So step number 1, you need to first look at the current. So do we have the current for the geyser? No. Now how can we find the current for this geyser? So it depends with the information that we have. So from the information that we have the voltage. Remember, the voltage for the geyser is 240, then the power is 4,000. So we are going to use these two values to find the current. So we said power is equal to VI. So to make I the subject of formula, we divide by V. We divide by V, so that current is equal to power divided by voltage. So the power for the geyser is 4,000 over 240. Voltage is 240, or we can just look at the point where we said voltage in a parallel circuit is equal at all points. So the voltage that is being produced by the source, this voltage is equal to the voltage that will be passing through each electrical appliance. So 4000 divided 240, I'm getting 16.6666, so which is 16.7 amps. So this is the actual current passing through the geyser. Now, how can we find now the fuse? So for the fuse, you need to get the number that you have, in our case 16.7, you add 0.5. So plus 0.5. So my answer is 17.2 amps. So that's what you are supposed to do. You find the current, then you add 0.5, or sometimes you can even add 1. So the point is, the current for the fuse must be greater than the actual current that is passing through that electrical appliances, because if the current of the fuse is equal to the current that is passing through that, then the fuse may be damaged even if there is no electrical shocks. So let's hope we've shared one or two. So if possible, subscribe and also comment where you are watching me from. So that's it for this video. Thanks for watching.